In this episode, we're going to talk about wide area network concepts. As we go through it, we'll talk about the ideas along the way. We'll be investigating various types of wide area networks by exploring a topology that uses diverse connectivity technologies. Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. This episode is part of my series on configuration examples for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. Packet Tracer Labs 7.6.1 Wide Area Network Concepts. I have the Packet Tracer file opened up. On the left side, we have our work area. This is where we're going to go in and explore all of our devices. On the right side, I have the instructions. The way bottom right is the Packet Tracer activity window that opens up and has the instructions in it. In the upper right, the majority of the right side, I have a Word document of those same instructions. Reason I'm using the Word document is we have questions to answer. The Word document will allow me to type my answers in and save them. Looking at our topology here, we have two big squares. The left blue square is the business WAN, wide area network. And we have some central locations, a headquarters, some stores, all listed in there. On the right side, this yellow box represents consumer wide area networks. This is your home. These are the devices you would use on a personal level. What we're going to do is we're going to explore these technologies that are used here in the business and home to get our data services. Part 1, investigate consumer WAN technologies for home and mobile devices. We're going to be looking at the big yellow square here, and well, basically in the center of the screen. Step 1, explore consumer wide area network technologies. In this step, we're going to explore 3 consumer WAN technologies and home networks. 1A, look at the 2 home networks. Okay, 2 home networks. In the yellow square here, in the center is one home network, and then in the bottom, in this purple square, is a second home network. So these are our 2 home networks here. What are the WAN technologies in use here? When we look here, we can see some descriptors on what we are using. In this top one here, in the center of the yellow box, we can see that it's labeled home cable network. We can see that there's a coax splitter. We can see that there's a cable modem. And so we are using cable to get our network access. So one WAN technology here is cable. And then the second home location, that's down here in the purple box, we can see that it's labeled home DSL. There's a DSL modem in here. And the network access for that second home is DSL. So cable and DSL WAN technologies. On to part B, examine the connections used in the network topology by selecting the connections icon, that orange lightning bolt in the Packet Tracer devices menu. Look down here in the way bottom left corner. This is our Packet Tracer devices menu. We select this orange lightning bolt. When I go over it, it will say connections right here in this white field. Now it changes it right below. Like, go ahead and make sure you click on it. Then this menu right here should pop up. There may have been already selected. This is what we are looking at. Hover over the media icons to display their names in the white box at the bottom of the Packet Tracer window. Now, when we go over these icons here, you can see right down here, right below my cursor, it's changing the names. And so here, this is a console cable. Then this is copper straight through, copper crossover, fiber. This is a phone line, coaxial, serial DCE, serial DTE, octal cable, IoT customer cable, and then we have a USB cable. So these are all different types of cables here. Question: what media is used to connect the 2 home networks to the ISP? What devices in the home networks are directly connected to the ISP? Let's go ahead and look at the top one here, or in the middle of the yellow box. This is a blue lightning bolt. So that technology, if we come down here to our menu, that is a coaxial cable. And then our answer here is for the cable network, we are using then they called it a coaxial cable. And that coaxial cable runs from the ISP, the internet here, into the house, and it goes into this device right here. This device is called a coaxial splitter. Now, if you can't really read that, you could click on it and it brings it up here, and here it says coaxial splitter. We're using a coaxial cable into that was a coaxial splitter. Then for the other network, the connection to the ISP into that home network is this dotted black line. If we look down here on our connections, the dotted black line that's with a lightning bolt, this is a phone line. And so the DSL network uses a phone line and then connected to, and then that connects here from the telephone company. It connects down in here to this DSL modem. So it connects right into a DSL modem. So DSL modem. On the part C, click the DSL modem and open the physical tab. So I'm going to come down here, click on our DSL modem. And we only have one tab, the physical tab. What are the ports that are available on the device and what is connected to them? Okay. Right here is the picture of our device, the back of them. We can see that we have a couple of ports here, maybe a little hard to see. What we can do is click on the zoom in right here. I'm going to zoom in. It makes it a little bit bigger. Look here, it says line 0, and then here it says fast Ethernet. Well, this line 0, that's the phone line that plugs in. Then here we have a fast Ethernet that goes to the home local area network. So our DSL, we have two ports. Okay, and then the phone line connects to the telco or service provider, depending upon how you have your DSL set up. The other connection, the fast Ethernet right here, the fast Ethernet connects to the home local area network. What is the purpose of the DSL modem? I'm going to go ahead and close the DSL modem window. The DSL modem, it sits between the telephone company and that phone line, and then the other side is the home network, the local area network. So it changes that signal from a data signal on the phone line to an Ethernet signal for our home network. So it converts the telephone data network signals to Ethernet for the home network. Modems do that conversion from one type to the other. Here we're changing it from that telephone data network into Ethernet so we can use it on the home network. What type of connection is between the ISP telco data company network and the home network? So we are now looking at the ISP and then the home cable network. So we are looking at this connection right here. So what type of connection is it between those two? Well, this is that blue lightning bolt. Blue lightning bolt, if we come down here, is a coaxial cable. So it's a coaxial cable. Now, why is the splitter necessary? Think about how cable works. Cable brings in all the signals over one piece of wire. Then that piece of wire has to deliver to the devices the appropriate signal. And the TV needs the video signals, the cable modem needs the data signals, and that coaxial splitter just splits it so we can connect multiple devices. So why is it necessary? The splitter is necessary because the cable carries both digital data and video signals. The splitter splits the media so that the data signal can be sent to the cable modem and the video signal to the TV or whatever device you're plugging into. On the D, look at the ports on the cable modem. So up here, I'm going to click on the cable modem. This is the cable modem in our yellow box. Go ahead and click on it. It says cable modem in the upper left-hand window, upper left-hand corner of the window. Here is the picture of the device. Once again, we can zoom in here and we can see the back here. On the back, we have this cable right here. It says coaxial below it. And then we have this connection, which is a fast Ethernet. What does the cable modem do? What connections does it have? Now, once again, this cable modem, it sets in between the cable running the signal in that came from the splitter, that came from your cable company, and then it sits and connects into your home local area network with Ethernet. So it changes that signal so it can be used by each one, either your home Ethernet or the cable provider, a signal they can use. So that modem changes signal. Okay, so what does the modem do? The cable modem converts the cable data signals to Ethernet signals. What connections does it have? It is connected to coaxial. That's our coaxial connection right here. That comes from the splitter and UTP, unshielded twisted pair cable here. So UTP cable from the Ethernet interface. Which port does the cable from the cable modem connect to on the home wireless router? Okay, let's go ahead and look at the home wireless router. I'm going to go ahead and close the cable modem. I'm going to open up our wireless router here. I clicked on it. I'm going to zoom in, scroll so I can actually see the ports here. Which port does the cable from the cable modem connect to the home wireless router. Now, once again, this home wireless router is going to do PAT, port address translation, NAT overload. It's going to have one IP address on the outside that's from the cable company, and it's going to have multiple addresses on the inside. Looking here, we can see that we have one blue cable connection, network cable connection, and then we have 4 yellow. Just by looking at the colors, because we're only having one IP address, it's going to connect into this one. Now, this one is typically labeled internet or your WAN connection. So what does it connect into? Connects to internet or WAN port. Where did the IP address come from? Well, the IP address that came from this internet connection that's going to have one that's this connection right here. Well, it didn't come from the coaxial splitter. It most likely came from the cable company, your service provider. And they're probably going to give it to you on DHCP. So the IP address came from DHCP from your cable internet service provider. E, look at the smartphone. Okay, up here's the smartphone. We can see it's connected wirelessly to this thing called a cell tower. So our cell tower is connected into that. What is the IP address of our phone? Okay, I'm going to click on our phone, slide it over here, and we can zoom in. This is what our phone looks like. We can go to desktop and we can click on IP configuration. Open up the IP configuration app. From here, we can see what our IP address is. Our IP address isn't set. There is no address here. But once again, how are we connecting into the network? We're using the cell tower. We're using the cellular signal. If we look at our interface right here, it says wireless. But we're not using our Wi-Fi home router. We're using the cellular router. So let's go ahead and take a look at the drop down. And if we, on the drop down, we can see that we have a 3G, 4G connection. If we click on that, now we can see what address we have got from our cellular provider. That IP address is 198.51.100.1. So what is the IP address? 198.51.100.100. Where did the IP address come from? Well, that IP address must have came from your cellular provider by DHCP. So the IP address came from your cellular ISP by DHCP. What data service is the cell phone currently using? Cellular data or Wi-Fi? Once again, we are connected into the cell tower. We are using the cellular data. We're not connected into a Wi-Fi router, so we are using cellular data. Cellular data. On to step 2. Step 2, in this step, we're going to explore the business WAN. We're going to look here at our blue square that has all of our business connections in there. In this step, you'll explore the business WAN. Business is a retail tire store. It has local headquarters where most of the business functions occur, and 3 stores that are connected to the business WAN. Here we can see this is the business WAN. We have store 1, store 2, and store 3. Each store location looks like they have 3 PCs each. and 3 stores that are connected to the business WAN. Look at the connections menu. What are the different types of connections do you see in use in the business network? So in this blue square, what type of connections do we have? Well, we have black straight lines. This black straight line here, that's a copper straight through. Then we have these red lines. Now in Packet Tracer, this red may also be orange depending upon how it is. So in practicality, this is probably an orange connection. If we look down here on our connections, we see that we have an orange connection. That orange connection is fiber. So these are fiber, these straight through connections here. Red and orange just don't render well here in Packet Tracer. So if it's straight in red or orange, that is going to be our fiber connection. So we have fiber is another type of connection. So fiber. And then here we have the black lines, we have fiber, we have more black lines, but then coming into this business headquarters router is a red lightning bolt. This red lightning bolt, if we come down here to our connections menu, is a serial DTE. So we do have a serial connection coming in. So and serial. So we have 3 types of connections: copper straight through, fiber, and serial. Open up the physical view for the store net switch. Right here, almost in the center, is our store net switch. Go ahead and click on that. Opens that up. Gives us to us in our physical view. Made it a little bit bigger. We can also zoom in. Here, as we look at our physical layout, we can see that we have different ports. We have some fans. Scroll over. We actually have power connected into it. What types of interfaces are present? You may need to zoom and scroll the view to see. So what types of interfaces are present? Looking over here, we have a couple connections down here. These are our console and auxiliary ports. So we have console and auxiliary. Console, our aux port. Then coming over here, we have the group of these ports. These here are copper media. They are probably either fast Ethernet or gigabit, so we have Ethernet ports. Scroll over a little bit more. And then we have these. These are modular connections. They're called SFP, small form factor pluggable. And what they are is when you first get it, they look like square little empty boxes that you can insert something in. And that's exactly what you do. You insert the module in there for what you need. These here, these first 3, these are fiber optics. So we have 3 fiber optics SFPs. So fiber optic SFPs. And then this last one is probably a gig port, another Ethernet copper port you can plug into there. And so we have a copper SFP. Which interfaces and media are used to connect the store networks to the business networks? Why was this done? Okay, I'm going to go ahead and minimize the store net switch. Connect the store networks to the business headquarters. So here's store 1 network. Here is the business headquarters network. What is this connection right here? This connection is this red or orange line. Red or orange, once again, signifies fiber. And so to connect those 2 up, to connect stores to headquarters, fiber was used. And then why was this done? Well, fiber gives us a couple advantages. One of the advantages is it's a faster connection than copper traditionally, especially over a longer distance. That's the second thing. Fiber goes a long distance compared to the other WAN technologies out there. So why was this used? It was used for speed and long distance. What type of WAN services is used to connect the business headquarters router to the ISP? Okay, so what types of WAN services used to connect the business headquarter router to the ISP? What we're looking at is this connection right here. This is that red lightning bolt. The red lightning bolt, if we come down here, is a serial connection. The serial connection. So, connecting, let's start that over. Router to ISP is a serial connection. That takes care of part one. On to part two. Explore connectivity. Ping devices within the business WAN and the consumer WAN networks. Also ping between the networks and the web server. Here's the web server. It's out here connected on the internet. It has an IP address of 209.165.200.226. And so a lot of these should be able to ping there. If you can't read that, you can mouse over. It'll pop up a window. It'll give you the IP address right there. 209.165.200.226. Now we need to open up a PC and see if we can do that. Let's start over here with the top left PC in the business WAN. Go ahead and click on that one. Open up our command prompt app. And let's go ahead and ping the web server. So ping, and then our address was 209.165.200.226. It may take a second. We'll probably have to do an ARP lookup, so the first ping will probably fail, but then the next one should work. To verify it, I'm just going to repeat it. Up arrow once, hit enter. All 4 pings should work. Okay, so that PC, store 11, can ping the web server. That's pretty good. Now let's see if we can ping something way over here. Let's go ahead and pick laptop 2. If I click over here, mouse over laptop 2, it's going to give me an IP address here of 192.168.0.100. What I did was I wrote it down so that way I can have it when I need it. So once again, open up PC1 here. And now I'm going to type in ping 192.168.0.100. Invalid command because I typed ping wrong. Let's go ahead and correct that. Up arrow, left arrow over, make the correction, hit enter. And now we're getting a report back that destination is unreachable. This destination is unreachable. We're getting it reported back by a device on our 10.100.100 network. Right here, odds are it's the IP address right here. This router is saying, hey, I don't know how to get there. Now, does that make sense? I think so, because this is on your private network. You shouldn't be able to access those devices on your private internal network. And so being able to connect to that, being able to ping that, that's a good thing. Okay, let's go ahead and ping PC1 down here in the headquarters. I'm going to get that IP address. Simply mouse over. It's going to pop up a window. Actually, let's open it up. Go to the desktop, open up our IP config tab, and here's our IP address, 192.168.104.2. I'm going to go ahead and write that down so I can have that. So 192.168.104.2. I'm going back up here to the store 1 PC, and I'm going to go ahead and ping that PC1 down in the headquarters. So ping 192.168.104.2. So is it timing out? Is it unreachable? Or were we doing an ARP lookup? Looks like we are doing an ARP lookup here. First ping failed, next three worked. I'm going to repeat that command here, up arrow enter. And now store one is able to communicate with the PCs down here on our network. Now, all the PCs, accessing all the PCs in our network, that sounds pretty good. I mean, it's all in your network. Now, you may not want that due to security reasons or other design issues, but right now, I mean, that could be a valid answer that your store PCs are able to access the PCs or even servers here in your headquarters. Now we need to try going the other way. Let's go on to laptop one down here in our home DSL network. Go to our desktop, go to the command prompt, and let's ping our web server. So ping 209.165.200.226. Thinking about it. Hopefully we're doing an ARP lookup. Timed out. There we go. 2, 3, and 4 pings work. Verified. I'm just going to repeat that command. Up arrow enter. And all 4 of our pings did work. So we're able to reach those devices. Now let's go ahead and try pinging PC1 here on the business network. Once again, I have that IP written down here. So from the home network on the laptop one, let's go ahead and ping. And then that IP address of PC1 is 192.168.104.2. Thinking about it. Gave us the timeout. And the second timeout, thinking we're not necessarily doing ARP lookups anymore. The chances we're actually doing ARP lookups are getting less and less with each failed request. Now let's think about what we did. We went from our laptop in the home here with the DSL network, and we're trying to ping an internal address on the corporate network. Now, should you be able to ping those addresses? No. If you want to be able to ping those, you may have to set up NAT with some global outside addresses or something like that to be able to ping those devices, but you should never be able to ping a private IP address across the internet. And that's why these aren't working when we try to ping inside of the other networks. Because those are private addresses, we are not able to communicate with them. Well, once again, because they're private. Okay, can all hosts ping each other and the web server? Well, all hosts could ping the web server. But hosts could not ping devices on the internal local area networks. That means if it had a private IP address on the internal side of your local area network, so all of these home networks have private IP addresses, all of these PCs here have private addresses, nobody from the outside could ping those. Now, is this a good situation? Yes, it's a great situation. Now, why is it a situation? These networks should not be directly reachable from outside networks for security reasons. That was Packet Tracer Lab 7.6.1 WAN Concepts. It was my pleasure to provide you with this wonderful episode on configuration examples. If you like this episode and you got value out of it, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. Thank you so much for watching this episode of my series on practical configuration examples for the CCNA. I've created 4 wonderful playlists for you on the CCNA. These episodes, I go through all the concepts that Cisco calls out for the CCNA. Once again, I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.